All right. So I've done the projection, and so I have all this information that I'm getting out of here. So I'm getting, so what am I spitting out? I'm spitting out, like I said, the world normal of the high res, the UV source of the high res, the AO mask from the high res, convexity, cavity thickness, and color. So the first thing I wanted to tackle was tangent space normals. So basically, I need to convert. If I look at my world space normal, right, I need to convert this world normal information here into tangent space information. So that is where I went back to the maps maker. So let's pop out of here and let's go into the maps maker, and all the stuff, all the magic, most of the magic of the maps maker happens inside of this cops baking module here. So this is the old compositing network in older versions of Houdini, and all of that is all the way. So basically, what this is doing is it's here. It's doing basically that same tracing action up here, and it's getting the world position that's traced, and then it's getting the position normalized and all this other stuff. But really, the main code that I wanted to get was from here, this nt, this cop generator. If I pop in here, when I come into here, there's world to tangent. So I basically took and just copied this pretty much wholesale. And then just kind of like I was like, okay, well, this is doing this and this is referencing this. So I kind of did like a conversion over to the new base, but it's pretty much the exact same. You can even see I have some of the same comments in here, just to like make it kind of make sense to me. So like I said, last lesson or last video, full disclosure, I'm not exactly sure how all of this works. To be completely honest, like this is like that bit of math where you're just like, oh no, I'm in a dungeon that's a little bit past, a little bit past my abilities, but it works, right? Like the logic is worked out for me. I will go back and figure out why this is doing what it's doing, because I don't like not knowing when I implement stuff and show stuff, but it works. So I basically just took this, duplicated it, or copied it into like onto a PureRef board and just had the PureRef board up and just kind of moved it around. So that's where all this logic is coming from. It's inside of this maps maker. So let's go all the way back out, and we'll go all the way back to our CopNet, and we will look at that. Let's see, our projection data. So I'm taking my world space normal out. I'm running that through a median. So that just kind of chills everything out a little bit. It chills, it's basically an anti-aliasing algorithm. So if I turn that on and off, you can kind of see it kind of smooth things out a little bit. This is 3x3. I could do 5x5, perhaps. That's shrinking stuff a little bit too much. Let's do 3x3. I could just turn it off as well, but I left it in there. Okay, so the next thing is we're going to go world to tangent. So this is the bad boy, and you can see it's not a lot of code. Like it's 19 lines of code, but what it's doing is very, very powerful. So I will try to explain what it's doing as best I can, but if at the very least, just know that like this code is in here. They've shown you how to do it. You need to just convert it over to your own needs. Okay. So what is this thing taking in? It's taking in the normal. So this is the normal data from the low res. So this is like low res. This is high res projected data. So I'm taking the normal. I'm taking that tangent U. I'm taking that tangent V. So those attributes came from the polyframe that's inside the import SOP. And then I'm taking in a world normal. And that's the world normal of the high res, which is this guy here, which I'm pulling with this projection data. And then I'm taking in signs as well. That's also coming from the polyframe node. So I'm taking all this, and when I do this, I usually immediately put this just into variables. So I'm taking normal one is my low res normal, and then tangent one and binormal one is my tangent U and tangent V from my low res. And then so they're taking the cross product of these, which gives me a new vector. Anytime you take the cross product of something, it's giving you a new vector. So I think what this is doing is building a new transformation space on the surface, and then it's using this madness. So basically what this is doing is it's saying this is my new normal, and it's normalizing the sign, which is I'm pretty sure the sign is negative or positive, and it's multiplying that by some new vector that this thing is generating overall. That's at least how I understand it. And then I have this out normal, and it's just moving that space around, and then I'm saying v out normal equals set normal x, normal y, and then this one is z. So that z vector, that's basically your your normal, right? So X, Y, Z, like Z is always, or is usually in Houdini. So that's setting that just to 1. And then if I'm saying invert Y here, I'm just saying 1 minus normal Y, because I know that at this point everything is normalized. So if I have a vector that goes from 0 to 1, if I just subtract 1 from that, it'll flip it over. I could also multiply it by -1, but that's neither here nor there. But that gives me, so what that transformed, it transforms this information into this information. And now this very, very much looks like what we're used to seeing in a normal map. So I'm seeing that now in here. If I do my invert Y, yeah, my invert Y is just flipping that Y direction. So I forget which one's which, but there's the two kind of render space. There's DirectX and there's OpenGL, and really the only, and one uses one type of tangent space normal, and the other one uses another type of tangent space normal. And really the only difference between them is that the Y is flipped. So if you're going out, like let's say I'm writing this out to Substance Painter or Unreal Engine or Marmoset Toolbag, and my normal map looks backwards, like if a light is shining down and the highlight is in the wrong spot, I probably need to flip that green channel. Most softwares give you they know this is going to be a problem, so they give you, like when you read in the tangent space normal map, there's usually a flip Y channel on that node, because it's so common to do. A lot of softwares kind of build that convenience in for you. But anyway, so that's my normal map, right? And then that goes to out normal, and then that kind of goes directly into, goes directly into here. So that's why we can see, that's why those little balls look raised and not completely flat, because I'm getting that new normal. I'm also getting the normal from the high res that's overrating those normals from the low res. So that's working quite well. So that's the normal. That's by far the most, this part here was by far the hardest part. Once I got that working, everything else was pretty straightforward. So one thing that I will say is I have like this red section up here. I'll probably delete this after this. So this was where I just completely fell on my face. Like I was trying to do like AO calculation, ambient occlusion calculation, and it just was not working at all. So this is my calculated ambient occlusion, and let's see if I can find, and that's my ambient occlusion from just pulling it off of the surface. So I just could not get it to work correctly. I'm not really sure what was going on there. I mean, and looking at this isn't too bad. It seems inverted. I'll mess around with that later. So maybe I was just looking at it wrong, but this is basically this is just raw information. And I also pulled this from the Maps Baker as well. So maybe I'll revisit this. Maybe I will leave it in there. I was just very, very frustrated trying to get so I was like, fine, I'll do it. I'll do it in geometry. So that's where that's coming from. So right now, I have my outworld normal, because I thought that might be useful to the end user when you're texturing. So I have my outworld normal. I have my tangent space normal. So those are the two that we went into. The other ones that I'm pulling out, these are coming just directly out. They're just like directly out of the projection setup here, this project data. So I'm pulling my ambient occlusion. I have this remap here that's not really doing anything. I'll probably actually get rid of those. Yeah, I'll probably get rid of those eventually, because generally, like I'm thinking of how like an end user would use this. If they really did want to remap this, because this would end up being inside of the HDA, if they really wanted to remap this, they'd probably do it on their own. Like, so I think I'm trying to do too many things at one time. But anyway, that's my AO. That's coming straight out. This is my convexity. This is my concavity. Yeah, so I don't really have that much convexity in here. Let's make sure I was grabbing the right thing. Yeah, so I don't really have that much convexity. I have a lot of concavity, and there's my thickness, and there's my out position, my out gradient position, and then my color. It's basically just sampling vertex colors. So yeah, like that's more or less it. Like most of it is coming just straight out of the projection, and then the tangent space just converts the world space. It's the world space converter for that, and then the world normal is just the world normal that I grab. So most of it is just straight out of the box, except for the tangent space normal. So yeah, that's the projection setup. So in the next video of this, I'll go over how I got from here, because this all here is just kind of, this is kind of like substance designer, substance painter ish style workflow. So I'll walk you through how I did that in the next one. So super exciting, really, really exciting. Like this is super fun. Because before I show you all this, I'll show you that this is still live. Like I haven't, there really is, as far as I know, there's no term for this, because it's technically, you would call it baking, but baking is the act of kind of sampling and then holding something in a file. This isn't really doing that. It's like some sort of live data streaming type thing. But anyway, so if I come up here and let's view our high res. Right, we can see that like this little bubble here is that little bubble there and that little bubble, and they're the same corner, like blue in there, blue in there. So that's all coming from this scatter up here. So if I change my global seed, those little bubbles on my high res will change. It's gotta cook, but then it will then automatically push that data into that CopsNet. So okay, so there it changed. So now I have like these two little blue bubbles here, this little green one here. So this is live. It's not real time, but it's live, and that's amazing. This so much democratizes the process, right? Because I could have a, you know, a texture artist, as long as they work, you know, procedurally, they can be working on like a super high res object. Like they could do poly painting, they can add stuff to it, and then I could have another artist that's working on the low res at the same time, and then they just feed both of their work into this like kind of like transfer mechanism, and it goes and it spits out the other, it goes out the other end. So that's, from a pipeline standpoint, that's pretty amazing. Now you would need like R&D people and engineers and stuff to like put this together, but you wouldn't have, in my opinion, I don't think you'd have to write a lot of code to do this. Like if you wanted to do this with like Blender and Substance Painter or something like that, you would have to write a lot of this interim code that makes those two softwares talk to each other. Like because this is all within Houdini, like Houdini talks to Houdini fine, even through its context. Like, you know, the SOP context talks to the DOP context, the DOP context can talk to, you know, the SOP context. Everything can, even though everything has kind of its own little language, they all can talk to one another. And as I showed before, COPS, you can directly just look at a COPSnet in Solaris now, which is absolutely huge. So that being said, it is still kind of wonky. It's brand new. It kind of crashes a lot, but the potential is very, very, very much there. So if you're still with me, good job. This one's way, way more technical than the other one. So yeah, so I'll cut this here, and in the next lesson, I'll show you how I took all that kind of like raw data and got to kind of this nightmare fuel result in the end. So hope you're enjoying it, and I'll see you in the next one.